Well, let's look at the multiple choice questions involving the string functions and procedures. And importantly, even if we could just immediately identify the correct answer, it's important to look at the others in terms of maybe just building an understanding of why the other answers are incorrect. So I'm going to go through each of the answers, including the correct one, obviously, and then the three detractors that are incorrect. First one is, which of the following statements about the pos function is false? Well, if you remember, the pos function basically searches for one string within another and returns a particular value. Okay, returns a particular value. So in the value that returns is an integer value, so that one is correct. So it's not false. Returns a 0 if the text cannot be found. Quite correct. It comes back with the position of the first occurrence of the one string within the other. And if it comes back with a 0, it means that string was not found in the other string. So that is also true. And in the third one, number D, it returns a value greater than 0 if the text was found. Yes, it does. So it finds the first occurrence of the text, or tries to, and if it's equal to 0, it means it wasn't found. But if it's bigger than 0, it means it was found at, say, position 6, whatever it is. Okay, this is the false one here. It returns location of the last occurrence. No, it doesn't. So, for example, if you've got two L's in the, let's say, the word Kelly, and you're looking for the L, it will give you the position of the first L, not the last one. So that's what doesn't, it turns up, so that should be the first occurrence if we get correct. So that answer there, number C, would be the incorrect one. Right, let's look at another one over here. Right, which of these are string functions and which are procedures? Okay, just a little bit about procedures and functions. A function is like a math function that returns a value. A procedure just carries out certain instructions. So, for example, show message is an instruction. Okay, and the quick way of thinking about whether it's a function or not is that if you can assign the result of a function to a variable, in other words, if you've got some variable there, and you can do that equals, and for example, pos or whatever it happens to be, then it's a function. A procedure, for example, like delete, you don't do that. It stands on its own, if you know what I mean. You don't assign it to a variable. You say delete from the string starting at that position, that many characters, whatever it happens to be. And the same with insert. So the ones that are both string procedures are in fact insert and delete, that one there. Length is a function, pos is a function, because we can assign that to a variable. Copy is a function, because I can assign it to a string variable uppercase. I can say string equals uppercase string 2, so I can assign it. Delete is a procedure, but lowercase is also a function, because I can say string 1 equals lowercase string 2. So as soon as I can put that function on the right-hand side of an equal sign, then you'll know it is a function. In other words, it returns a value that can be used. Right, let's go on to the next one. Right, and again, it often helps, and I often repeat this in class, and we say, you know, we need to be able to think about how we would do this in real life, and then think, okay, what is the Delphi equivalent? In other words, how do I translate it into Delphi? Because the solution is not Delphi. Delphi is the implementation. Which two functions could one use to extract the class C4 of the pupil from the string this? Okay, so we've got sDetails equals C4, which is the class, comma, Gracie Hopper. Okay, so that's so I need to extract that. So from a human point of view, we just say, well, it's C4. Okay, how did we actually do it? Well, what we said was, well, it's obviously this part here up to the comma. So in other words, I did two things. I found the position of the comma. I would need to find the position of the comma, so it would be position 3, for example, at this stage, and then I would copy all the characters before that. So I would copy the first two characters. So I'm going to have to first of all find the position of the comma. Okay, so that's the pos function, and then I would copy from the beginning of the string, in this case 2 characters, but it would depend on how the class is named. In this case, it's got 2 characters to identify it, so it would be a position and a copy. Okay, so first of all, pos to find the position of the comma, and then copy to go and copy it. up to the string, but not up to the comma, but not including the comma, obviously. Let's look at number 4. This one's an interesting one, and sometimes it helps to think of a practical example. What can be deduced or worked out if the following if statement is true? Okay, if you take the uppercase of something, and it's exactly the same as the lowercase of that same string. Okay, let's think about it. If there were capital letters in it, there's no ways that the lowercase would be the same as the uppercase. That's just not possible. Okay, so number A would be out. And by the same token, any letter stored in SNU or in lowercase. No, well, if you think about if that lowercase, if you take the lowercase, let's imagine a string with only lowercase letters in it, then the uppercase version of that is not going to be equal to the lowercase version of it. So there's definitely, in other words, what we're leaning towards here is that there can't be any letters going on in this thing. Yeah. Okay, there are no, which it means that number C is starting to pop out, but let's look at number B. It contains only letters, nothing else. No, it definitely doesn't contain letters. In fact, that can only be true if there are no letters at all. So that could actually be used to see if there are no alphabetical characters in there. Okay, so that could be one way of checking it. So that just means there are no letters. It can be other things, of course. It can be digits, exclamation marks, and hash signs, because they're not influenced by the uppercase and lowercase. So the answer there would be that there are no letters. Okay, what we obviously mean letters of the alphabet, either uppercase or lowercase, that are stored in there at all. All right, moving on. Which of these correctly assigns the value of string 1 to SNU? Okay, let's look at the start from the beginning. Very good place to start. That says insert into SNU string 1, comma 1. Okay, that's a possibility maybe. Let's have a look at that. Look at number A. It looks very tempting because it says insert the new string into the... But wait a bit, that seems to be the wrong way around, because I want to take the value of S string and give it to new. In fact, if this had been swapped around, that actually would have actually worked, because then I would have said insert the contents of the string, S string 1, into S new at the first position. So that would have worked had these been swapped around. But this is saying starting, and we can correctly assume that S new is a blank string to start off with. Okay, so that is tempting, but it's those two things are the wrong way around for it to work. Copy from S new. Okay, now we don't want to copy from S new. That's another one that looks as if it could have been something, but we want to copy from the string because we want to assign it to S new. That's fine. But we certainly don't want to copy from S new because S new is blank to start off with. So we can reject number B. Let's look at number D. Copy from string 1, comma 1 to the position of the full stop. Okay, well, we have no idea if there's a full stop in there. It would only work if the full stop was the very last character in S string 1, and we have no knowledge of that. In other words, it must work for any contents of string 1. So we assume number C is the correct one, and if we think about it, copy from the string, that's right, from the first position, how many characters, well, however many characters there are in the string. So if there are 10 characters in the string, let's assume it's an ID number, or a cell phone number, sorry, then we would copy 10 characters. So that one is the correct one, to copy all the characters from one string into another. Okay, so it would be a lot easier just to have said S new is equal to string 1, obviously. 1.6. Which of these will always correctly delete the last character in string 1? It must work irrespective of what the contents are. So immediately I'm just looking at number A, and that's again trying to find the position of a full stop. Well, you have no idea what is actually going to be stored in string 1. There may not be a full stop or anything, so I'm not even going to look at that one any further. I'm going to take that one out. Let's look at the others, starting at the bottom here. Delete. Okay, from Okay, delete, they want to delete the last character. So that deletes from the first position, so immediately that doesn't sound right. And then they want to delete for the length of the string. So that would in fact delete the whole string. It would take everything out, because that would be 1, and length of S string would work out the number of characters. And just the fact that it's deleting from S1, we're taking that one out. Okay, and we've taken those out. So we're left with B and C, which look quite similar. So let's have a look. The length, basically what I want to do is I want to have let's say the string has 10 characters, then I want to delete from the 10th position 1 character. And if there are 20 characters in the string, I want to delete from the 20th position 1 character. And if there's 100 characters in the string, I want to delete from the 100th position 1 character. And so I'm leaning towards that one there, because that's exactly what we want. In fact, is the correct one, number B. Okay, this one is just going to be 1 out. You don't want to delete this. That would delete the second last one. Okay, so let's just say the string was 10 characters. That would start at position 9. You don't want to delete from position 9. You want to delete from position 10 if they're 10 characters. So that would work correctly. And again, it often helps to think of a practical example. So be careful on one hand to make them very specific examples that only work for that example, but it does help to visualize a string and say, okay, let's say there were 20 characters, then I would want to delete from the 20th position 1 character. Okay, number 1.7 says, what will the value of R length be after the following 2 Delphi lines of code have been executed? Okay, so they delete from the string and they do something, and then they work out the length of the string. So we've actually got to work out what that delete's going to do. Okay, you might say, but I don't know. I don't know what the value of string 1 is. Okay, but it actually doesn't matter, as we'll see. Because if we take any string, let's imagine a string of 20 characters again. Okay, then if I delete from the first position of that string 20 characters, it's going to delete all the characters. Okay, and if the string had 100 characters, then I would be deleting from the first position 100 characters. So every time it would delete all the characters in the string. In other words, I would end up with what we call the null string. Okay, so in Delphi, when we write it as that, okay, in other words, no space or anything, that's the null string, which then has an effective length of 0. Okay, so it is possible to predict. And that length is then 0. It's not 1. Okay, it could have 1 if there was a space in it, but there's no space. It's, in other words, consists of 0 characters at that stage. That was 1.8. Obviously, in any when you're given these things in a multiple choice format, you can obviously box smart and maybe look at eliminating some of the possibilities. But we're just going through them from a point of view of saying, okay, well, let's look at all of them. Even if you can eliminate some of them would be quicker to eliminate than others. Which of these for loops will correctly count the number of lowercase vowels? Okay, so in other words, small a, small e, small r, small o, small u, and they're saying assume that I count's been initialized to 0. Okay, well, they're all running the same loop, and that loop looks correct because it's running from 1 to the length of the character. Okay, it's running, the length of the string, So that the for loops are all correct in all the cases. And then in all the cases, it's looking at the individual characters. Because again, let's imagine S new consisted of 10 characters. It would look at R loop would become 1, then 2, then 3, then 4. Okay, so it would become 1, 2, 3, 4, all the way to the length of the string. So in this case, and that's the standard way of saying, right, let's process each character. Right, if the lowercase version is in A, E, I, O, U, it looks tempting, but the problem is, what happens if one of those things in the string was uppercase? Okay, so let's just say the string that we had had something like this in it, A, U, and I. Okay, we don't want to count that capital A. They only want the lowercase. So now that's going to say, that would say, right, take it as a lowercase version. Okay, take it as a lowercase version, and if it's in there, so it would count it, and you don't want that. So that one we're going to remove because we don't want that one. Okay, is this character in that one there? Now, it looks promising. That looks promising, because what we're saying is right, but let's double check it we've got this right. Okay,